Welcome back. In our last lesson, we saw how logistic regression uses a mathematical function to classify data. Today, we're going to explore a completely different and much more intuitive type of model, the decision tree. A decision tree is one of the most popular and easy to understand algorithms in machine learning. It makes predictions by learning a series of simple if-then-else rules from the data. The best analogy is the game 20 questions. The tree asks a sequence of simple questions, and based on the answers, it follows a path down the branches until it reaches a final conclusion. Every tree has the same basic anatomy. It starts at the top with a root node, which is the first question that considers the entire dataset. Each time a question is asked, the data is split, leading to internal nodes. This continues until we reach a leaf node. A leaf node represents a final prediction, and no more questions are asked. So how does the tree learn which questions to ask, and in what order? At each node, the algorithm looks at every possible feature and every possible value to split on. It then calculates a score for each potential split, usually based on a metric like Gini Impurity or information gain. It then chooses the single question that results in the purest or most separated groups of data. It repeats this process greedily at every step. Decision trees have some major advantages. They are incredibly easy to understand and visualize, and they can naturally handle both numerical and categorical features without much preprocessing. However, they have one huge weakness. They are extremely prone to overfitting. A single tree can easily grow too complex and memorize the noise in the training data. Their biggest strength is their interpretability. Unlike black box models like complex neural networks, we can look at a decision tree and understand exactly how and why it made a certain prediction. We can trace its entire logic, which is critical in fields like finance and medicine. And now you can think like a tree. You understand this powerful and transparent model. But how do we overcome its major weakness of overfitting? The answer is not to rely on one tree, but on hundreds. In our next lesson, we will explore one of the most powerful algorithms in all of machine learning, an ensemble method called random forests.